In this example, we are going to be using the power rule of exponents to be able to solve for these equations here. Now keep in mind, for letter A here, we could see that we have a base here. This is the base for an exponential equation or for an exponent. We have a base here. The base here just happens to be x, and then we have a power here. That's our exponent to the 24th power. So what we're going to determine is what to the 24th power is equal to 1,345. So we're going to solve for this. Now what the power rule says, the power rule of exponents says that if we have something like, let's just say 3 to the second power, and then I raise that to the third power, this is the same as 3 to the second times 3 power, which means 3 to the sixth power. So if you can imagine 3 to the second power, that's 9. And then 9 raised to the third power. So then 9 to the third power, using our calculator, that's 729. So that's what this should be too. So I'm going to take 3, raise that to the sixth power. And that's also 729. So with that understanding, I could also do this. If I have 3 to the second power, and then raise that to the 1/2 power, we can have exponents that are fractions. Then that must mean 3 to the second power times the 1/2 power. 2 times 1/2, that's 3 to the first power. Or in other words, that's just plain old 3. So what happens is when I have an exponent here, such as 2, and then I raise it to its inverse, such as 1/2, these wind up canceling each other, leaving us with just the base here. And that's the idea. So we're going to use that same principle to solve for each one of these. So for A, I have x to the 24th power. That's equal to 1,345. So using some algebra, I'm going to raise this to the 1/24th power. And then algebra says what I do on one side, I got to do it on the other side. So I'm going to raise this to the 1/24th power. So when I have x to the 24th power, and then that's raised to the 1/24th power, these are going to cancel each other. So then I'm just left with x. So then x is equal to 1,345 to the 1/24th power. Well, what is 1,345 to the 1/24th power? Well, we'll use our calculator. So I'm going to take 1,345, use my caret key, and I'm going to raise that to the 1. 1 over 24 means 1 divided by 24, and then hit enter. So that's approximately 1.3500922. So 1.3500922 raised to the 24th power is going to give me 1,345. So I'm going to check that. So I'm just going to clear this for a second. I'm going to type in 1.3500922, and I'm going to raise that to the 24th power. Hit enter. Now I'm never really going to get 1,345 exactly because I'm rounding this to 8 decimals, but it's pretty darn close. So we'll try letter B. We have a to the 365 power. That's equal to 13. Again, using the power rule for exponents and some algebra, I'm going to raise this to the 365th power. And I'm going to do it on this side. These will cancel. That's going to leave me with a is equal to 13 raised to the 100 over 365th power. So then I'm going to go over to my calculator. I'm going to take 13, use my caret key to the 1 over 365th power. And that's approximately 1.007052. Since we have these 0 zeros, it rounds right to there. So rather than check this, one way to check this is if I just go ahead and raise this to the 365th power, it'll get me exactly back to 13. That's because what is displayed on your calculator and what is held in memory are two different things. Your calculator can only display so many decimals, but in memory it holds hundreds of decimals. So I like to check it by taking 1.007052 and then raise that to the 365th power, knowing that it's not going to be exactly 13 because I'm truncating this. I'm rounding this to so many decimals. So my result, when I go ahead and check it, are going to be rounded. So I hit enter, and I come up with 12.9999, and you can see that it's pretty darn close. So I think we're okay. Here's C. That's 1 plus y, and that's raised to the 35th power, and that's equal to 6.5. Again, using the power rule for exponents, I'm going to raise this whole thing to the 1 over 35 power, and with algebra, do the same to this side. These are going to cancel. That's the whole idea. So I'm left with 1 plus y, that's equal to 6.5 to the 1/35th power. 6.5, raise that to the 1/35th power. So this is 1 plus y, that's going to be equal to 1.05493596. However, I want to know what y is, so I'm going to subtract 1 from either side. Therefore, y has got to be equal to 0.05493596. We can check that. If I take 0.05493596, slug it in right here, add 1, that gives me 1.05493596. Raise this to the 35th power, so I'll do that. 1.05493596. Raise that to the 35th power, and very close to 6.5, which is what we have here. And then finally for D, we have t to the negative 12 power. You can have an exponent that's negative. That's going to be equal to 17.55. Again, using the power rule for exponents, I'm going to raise this to the negative 1/12. Negative 12 times negative 1/12, they'll cancel each other. They become positive 1. And then I'll raise this to the negative 1/12. So these wind up canceling. That's the whole idea. So then t is equal to 17.55 to the negative 1/12 power. Back over to our calculator, 17.55. Raise that. We have our negative right here. Negative 1/12. Hit enter. That's approximately equal to 0.7876 0822. If I take 0.7876 0822, raise that to the negative 12th power, I wound up with 17.549999, very close to 17.55. So I think we're good.